Okay, we're getting to our bonus question. We're getting there. Please do guys stick around, stick around, stick around. We're getting there. Okay, now I think this one now says we should have real roots, so we know that now when we're dealing with real roots, our discriminant firstly has to be greater than or equal to 0. That's when we know we have real roots, right? And the reason, okay, now it says that determine the values of p for which the equation will have real roots, right? But then we know that p must not be equals to 0 in this case. So whatever values we get, it shouldn't be equals to 0. But let's keep our value of the discriminant as greater than or equals to 0, right? Okay. Um. Now, what do we do now? We ask ourselves: is this equation in standard form? No, it's not. We have 1 over p. We have equals to x squared minus x plus 1 and stuff. Now, you remember like how we do algebra, we always like doing the opposite of what's being done. So here we have 1 over p. We have to do the opposite of dividing, which is multiplying to get rid of the p on this side, on this left hand side here. So I'm gonna switch screens and then we're gonna do it together. So it's, let me just take this down here. 1 over p x squared minus x plus 1 plus 1, right? Okay, and then let's now, oh sorry about that, let's now do this. Okay, so now from here we're going to say that, okay, so determine the values of p, right, for which would have real roots, right? Okay, so we know that this is 1 over p is equals to x squared minus x plus 1 plus 1. Okay, so some people would just want to multiply the p throughout, so whatever you do on the left hand side you do on the right hand side. So we know that this is gonna multiply here, x squared also multiplies with p, and then minus x will also multiply with p, and then plus 1 multiplies with p. We know that this and that will cancel, since we're left with 1 is equals to px squared, and then we have minus xp, and then plus p plus p plus p plus p. Let's try to put this one in standard form. I don't like how it's like. So this becomes 1 is equals to px squared minus px plus 1 times p, which is p. Now this makes sense. Yeah, so in this case, like I said, guys, it's not always gonna be a. There are always gonna be different values, different variables. But like I said, every question you're gonna do in maths, you always learn a skill. Oh yeah, and I also wanted to clarify that for the previous question that we did, I think it's supposed to be p is less than negative 9 over 2, because I remember transposing the 36, so it's supposed to be negative. So sorry about that, right? Sorry about that, but I hope it made sense to someone still. But yeah, now with this one now we know that, okay, let's see, is this standard form? Okay, it's looking much better, it's almost there, but now we have to transpose this one to make it into standard form, right? So let's say that, okay, now we know that this becomes what now? This becomes px squared, right? Px squared minus px plus p minus 1, for which the roots will be real roots, right? There will be real roots, so we know that it's greater than or equals to 0. I forgot to say that my discriminant must be greater than or equals to 0, because then I get a mark there. Okay, then from there we do know that b squared minus 4ac must be greater than or equals to 0. And now we're just going to substitute whatever we have. We're going to substitute whatever we have. In this case, we're going to have negative p, right? So this becomes, in this case, we're going to have negative p, right? Negative p squared minus 4 into a. Now our a is no longer 1. Now it kind of changed a bit. It's now a variable now. Now our a is now p. Let me just confirm that it's actually p. Yeah, it's p. Close bracket, and then our c was p minus 1, right? Yeah, p minus 1. Let me just confirm that p minus, yeah, it's p minus 1 and negative p. Okay, that's good. Okay, now it makes sense. Then from there we're gonna say, okay, because it's raised to an even exponent, we know that this ends up as p squared minus 4 into p times p is p squared, and then p times negative 1 is negative p, and then from there we're going to have p squared minus 4 p squared minus positive negative is positive plus 4p, and we know that in this case this is going to be basically greater than or equals to 0. So we do know we're going to group like terms. So what's p minus 4 is negative 3. You agree? This becomes negative 3p squared, and then this becomes plus 4p, which is greater than or equals to 0. And then from there, let's apply some algebraic skills. So we know that when we have p squared and we have p in both terms, we know that we're dealing with a binomial here. And because it's a binomial, we can take out a common factor of p, right? And then we have negative 3. Because it's p squared, it multiplies into itself. Because it's p squared, yeah, it's going to multiply by itself, p times p, then plus, right, plus 4, yeah, plus 4 greater than or equals to 0. Then we could divide both sides by p, and then we have negative 3p plus 4 greater than or equals to 0. Transpose negative 3p is greater than or equals to negative 4. And I think this is what I was talking about. When we divide by a negative on both sides, the inequality sign will change. So that means that p in this case would then be less than or equals to 4 over 3. And then that's for which you would have real roots, right? Please do test your answers, guys. Don't please do test. And I think where you're gonna test, you're just gonna say that from here you can test. You're allowed to test from. Yeah, you can test from here. You could test. You could put in the values and then see what it gives you. Yeah, but I hope it made sense again to someone. I really do hope it made sense to someone. Okay, thank you very much. Let's move on to the bonus question now. Oh, that was long.